We'll proceed in summation to integral. Okay, so we are pursuing discussion in summation to integral. How I can convert summation to integral. What is summation? What is integral? Okay, many times we have described it. Summation is how I can divide my problem into n part and then solve the problem part by part and then sum it. Okay, means solve the problem part by part and do whatever you want. One example I had given, that consider that I have 10 rupees. I have 10 rupees. 10 rupees. And I have set of n coins. Set of n coin. Each coin would be head or tail. Then I throw it. Okay. Now, if number of heads are 4, consider number of head are 4, then I would double the uh, rupee value 4 times. Makes sense? So if the rupee is 10, if I see one head, it becomes 20. If I see another head, it becomes again double. So it will become 40. If I see another head, it becomes 80. And fourth head, if I see, then it would become 160. So my 10 rupee become 160 if I throw n number of coins and I see 4 head out there. If I see 10, then 160 will become 180. Sorry, 160 will become 80. If I see another 10, 80 would become 40. If I see another 10, it becomes 20. If I see another 10, it becomes 10. If I see another 10, it becomes 5. If I see another 10, it becomes 2.5, like that. So if I throw n number of coin and let's say that there is a alpha number of head I am finding, then n minus alpha is the number of tail. If I have a rupee and its value is C, its value is C rupee. Okay, its value is C rupee. Then how much the value of the rupee after throwing the coin, n number of coin, when number of head is alpha, so number of tail is n minus alpha. It will be C into alpha to the power C into alpha to the power 2 into n minus alpha to the power 1 by 2. Yeah, it will be it will be 1 al, al n minus alpha to the power 1 by 2. Okay, I'll rephrase this. If it comes head, then I have to double it. If it comes tail, then I have to half it. Okay, then it will become now C, that is the initial money I am carrying, C into 2 to the power alpha into 1 by 2 to the power n minus alpha. That much, that much is the money I will have after I throw n number of coin and there is alpha head and n minus alpha tail. Okay, question is arising now. Question is arising. I am considering the probability of head and tail is 1 by 2. If I, for each coin, head and tail probability is 1 by 2, 1 by 2. It can be different also. If coin is biased, then there is chance that head will be, probability of the head will be 2 by 3 and probability of the tail will be 1 by 3. Right now I am taking 1 by 2, 1 by 2. Okay, the question is arising, what is the expected value of the rupee or dollar, whatever it is, that is initially C, when I throw n number of coins? This is the question I kept on repeating. Okay, if I throw n number of coin, if it is head, then my rupee value, that is C right now, it would double. I see coin by coin and I count how many heads are there and how many tails are there. For head it would double, for tail it would become half. So if the number of head is alpha, the number of tail is n minus alpha. Then the C currency, C is currency, the currency I have right now, it would become C into 2 to the power alpha into 1 by 2, 1 by 2 into n minus alpha. what is the expectation of my average expectation of the C when I throw n coin? That is one question. Second question is, consider that the getting head probability is 2 by 3 and getting tail probability is 1 by 3. Then what would be? This is one question. Second question is, person is standing. He is standing. Okay. Now he is throwing a coin again. Okay. He is standing. This is x-axis. This is consider this is origin. If this is origin, then this is x-axis. If this is origin, this is minus x-axis. Person is standing at the origin and he is tossing a coin. If coin comes ahead, he will leap. He will make one step forward in x direction. If it comes tail, then he will come backward in the x direction. Means if he is at origin and it comes tail, then he will go along the minus x axis. If it comes head, then he will go along x axis. Makes sense? Now consider that he is throwing n number of coins. Number of heads he is seeing, that many steps he is making forward. Number of tail he is saying, that many steps he is making backward. These are similar questions. Now, what is the expectation? What is the expectation that if I throw n coins, then what would be his position? Average, on an average. I'm not saying that luckily and bad luckily or what. These are the questions can be solved through the summation to integral calculus. Means we will divide problem into n different parts and try to solve it part by part, and then we will come to the answer. So that is the fundamental of summation to integration. Right now we are in a phase of calculating the area of a circle. Area of a circle, when I am dividing the area of a circle into n different parts. I believe it is all right. Okay. Okay. Now I have a circle. As per promise, I am showing the circle. If I have a circle, what is area of the circle? Area of the circle, to get the area of the circle, this is the x-axis and this is the y-axis. This is x-axis and this is y-axis. Now I have, this is Cartesian coordinate system. In Cartesian coordinate system, in Cartesian coordinate system, I am pushing polar coordinate system also. What is polar coordinate system? Where x equal to r cos theta and y equal to r sin theta. In that fashion, we have x square plus y equal to r square. This looks like a circle. Indeed, I have a circle in xy plane where this is x-axis and this is y-axis. To get the area of the circle, I take the radius and move the radius, making radius is constant. Radius is not changing of the circle, where angle is changing. In that fashion, I divide this area into n different parts. This is the part number 1, part number 2, part number 3, part number ith part number n. Okay, part number n minus 1, part number n minus 2, part number n minus 3, part number I, part number 1. Okay, I have divided into n parts. What is the area of the circle? That is summation sigma sine. Summation I equal to 1 to n. Summation I equal to 1 to n. Area of the ith section. Summation sine I equal to 1 to n. Area of the ith section. Okay, that is the, if this is the area of the ith section, then if I sum it for all I get the area of the circle. What is the area of the ith section? That is under question mark. So to get the area of the ith section, one thing I can do, to get the area of anything, I have to multiply two items. That is for sure. Area can be generated by two variables. A length can be generated by one variable, whereas volume can be generated by three variables. A weight can be generated by four variables, okay, if it has density. Anyway, so if I am talking about the area, then I have two variables. Okay, then if I talk about the Cartesian coordinate system and polar coordinate system hybrid model, this is Cartesian coordinate system. This is Cartesian coordinate system. And this is polar coordinate system where this angle is theta. Now in this model, which is basically a Cartesian coordinate system, I have embedded polar coordinate system inside it, where x equal to r cos theta and y equal to r sin theta. In that fashion, x and y are dependent upon r and theta. R and theta are independent and x, y are dependent. If I have two independent components, then cross product of the length vector along the independent component would bring the area, help in getting the area. I don't want area of the circle as one go. I want area of the ith section. If this is the ith section, this is the ith section. What is the area? Then summation I equal to 1 to n area of the ith section. It will give the full area. What is the area of the ith section? This is radius vector and this arc is the arc vector. This is this arc of the ith section. Up, 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 up. This is the arc of the ith section. This is the arc of the ith section. If this is the arc of the ith section, then if I do cross product of this radius vector and arc vector, this is arc vector. If I do cross, then I can get a hint in getting the area of the ith section. Okay, cross product of this vector and this vector will give the area in between. Like cross product of these two vectors give the area in between. Like this cross product of the radius vector and the arc vector will give the area in between. But I have to find area of the ith section. Makes sense? Now, in that fashion, if I see the area of the ith section, there are two variables. One variable is angle is changing. This angle, consider ith section angle is delta theta I. And radius may change. Radius may be function over theta, like r equal to cos theta. In that way, if I talk about the ith section, entry radius is different and exit radius is different. In that way, if this is r1 and this is r2, in this area, r1 changing from r is changing from r1 to r2. There is a delta r change, and theta is changing. This is x-axis. This is theta. This is this theta, and this is this theta. Theta is changing. That is delta theta I. R is changing. That is delta r I. I belongs to ith section. Anyway, if I do cross product of this vector and this vector, okay, it would give a hint of the area. Now, what is cross product of these two vectors? If I talk in polar coordinate system, polar coordinate system is different. In if I talk about the if I take a circle like this, and this is point P on the circle, then this point P can be represented through Cartesian coordinate system, x comma y. Whereas this point P can be represented in polar coordinate system as r comma delta r comma r theta. R theta is the arc from here. So this point is r comma r theta. If I convert x and y to polar coordinate system and this point is x comma y, this point can be rewritten as r cos theta I plus r sin theta j. If people are not very understandable in pure polar coordinate system, that is r comma r theta, then they can understand it as xi plus yj, or as a or x comma y, r cos theta comma r sin theta, or r comma r theta, whatever is. So first will become, if I take position vector, first will become r cos theta I vector plus r sin theta j vector to any point x comma y. Or if I take in polar coordinate system, it will become r unit vector plus r theta unit vector. Okay, in r theta, r is constant and theta is variable. This is something. Now we can change it it into the length vector. Length vector is our invention. Length vector is a vector that represents a curved line, straight line whatsoever. If I want to represent this straight line as a length vector, I have to see what is variable. If this is x-axis and this is y-axis, and y is dependent upon x, y is a function over x, then x is variable. If it is a straight line, then this can be represented as 0, 0 is the origin, and this point is x, y. This can be represented as xi plus yj. If x is variable, I can take out x. It will become I plus y by xj bracket close into x. Okay, I have taken out x because x is variable. It can be rewritten as I plus dy by dxj bracket close dx. This is the full form of representing any line as a vector, curved line also. Now, if I am trying to calculate the cross product of this length vector and this arc vector, this length vector is r vector, and this arc vector, this length vector is the, if this point is P, then this length vector is P. If this point is P, then this vector also I can say P. Means to get the length vector of the arc, I would take theta as independent variable, and to represent this length vector along the arc, I'll take r as independent variable. Cross product of these two means r unit vector, r unit vector plus r theta unit vector. I have to take out r here. Cross product r unit vector plus r theta unit vector. I have to take out theta from there. Okay, if I convert into calculus, it will become, first one will become dr by dr I unit vector plus r d theta by d theta unit vector. Bracket close dr. Cross product in bracket dr by d theta r unit vector plus r d theta by d theta unit vector. Bracket close d theta. Okay, then we can rewrite as dr by dr r unit vector plus r d theta by d theta unit vector. Cross product dr by d theta r unit vector plus r d theta by d theta unit vector. Okay, dr d theta, just leave it. First, these two can be rewritten as dp by dr cross dp by d theta, where p is r unit vector, r theta unit vector, dp by dr by dr r unit vector plus r d theta by d theta unit vector. Okay, this plus dp by d theta. Okay, now what is dp by dr cross product dp by d theta? That is dp by d theta r. dp by d theta r, if I combine it in an abstract manner, not a very physically manner, logical manner. This shows that if there is 1 unit of area change in theta and r, d of p, d of position vector by d of theta r, if there is 1 unit of area change in theta r, brings how much area we have described in previous video also. dp by dr theta, if there is 1 unit of change in theta r, brings how many unit change area in p, dp. If that is the case, if I know that much, if I multiply it by delta theta I and delta ri, then I get the area of the ith section. So I can rewrite now summation I equal to 1 to n, that is area of the circle. Summation I equal to 1 to n, area of the ith section, and area of the ith section is dp by d theta r into delta theta I delta ri. Earlier it was dr d theta. I convert into delta theta I delta theta r. Okay, dp by d theta r can be broken again the way it was, dp by dr cross dp by d theta. Position vector can be written as xi plus yj also. So dp by dr cross dp by d theta can be rewritten as d of xi plus yj by dr cross d of xi plus yj by d theta. Okay, if I talk about the hybrid model, then it will become d of r cos theta I plus r sin theta j by dr. Cross product d of r cos theta I plus r sin theta j by d theta. If someone can try doing the cross product, there is nothing like that. What it will become? dp by dr, keeping theta constant. Anyway, if I go along the r radius, then theta is constant. There is no theta movement here if I go along this length vector. But in this arc vector, theta movement is there, r movement is also there, r may change. Anyway, now if I proceed in this manner, then it will become cos theta dp by dr, cos theta I plus sin theta j, dp by d theta. If I do keeping r constant, consider r constant, it will become r minus sin theta I plus r cos theta j. If I do cross product of these two, then I and j will cross. That is cos and cos will cross. Okay, so I'm sorry, cos, here it is cos theta and there it is r cos theta. It will become r cos square theta and this one become r sin square theta. K vector, cross ij cross vector is k vector. It will become r cos square theta plus sin square theta in bracket r. It will become r. So we can say r if r is constant. If r is not varying in the ith section, r is same, then it becomes r delta ri, delta theta I, dr d theta. Okay, this is the ith section area. R of the ith section delta ri, ith section delta theta I, summation I equal to 1 to n. Okay, please watch our previous video. This is similar to r into delta theta r into delta theta r. More or less, r can be written as function over theta and r. Makes sense? Function over theta and r. If it is function over theta and r and delta theta r of the ith section, it is same as I have a axis that is theta and r together, and this axis is function over theta and r. If I have a line like this that is function over theta and r, then function over theta and r at ith section into delta theta r of the ith section gives this section area. What we are doing? We are doing summation I equal to 1 to n function over theta r delta theta r of the ith section. If this is theta r axis, I chop it into n part, and if I take the ith section, first section, second section, third ith section, its width is delta theta r ith section. Function over theta r here will be like this. If I multiply, it gives the area of the ith section. If I add all the area, it is as good as integration only. So it can be converted as integration of theta r from beginning to end, and then f theta r d theta r. D theta r will become d theta dr, and function over theta r is r d theta dr, and integrate. It becomes pi. It will become pi r square. That is the area. People can go with the other way. We had summation I equal to 1 to n dp by d theta cross dp by dr. Okay, dp by d theta, if p where theta, dp by dr where theta is constant and p is r unit vector, r theta unit vector, dp by dr will become r unit vector, d theta by dr will be 0. Cross product dp by d theta, that will be dr by d theta r unit vector plus r d theta by d theta unit vector. If r is function over theta, still we have to do cross product with the r unit vector and theta unit vector. R cross product will be 0. Okay, if it is like that, in that fashion, if it is like, still it will be r k unit vector. If it is cylindrical coordinate system we are taking, r theta and r unit vector, theta unit vector, cross product will be k unit vector, r k unit vector, magnitude will be r1. So it will come to the same result. It will come to the same result. Anyway, someone can try in earlier one, dp by dr where theta is constant. In that fashion, it becomes cos theta I plus sin theta j. dp by d theta where r is function over theta, then it becomes d of r cos theta by d theta. It will become dr by d theta into minus sin theta plus in I vector only plus sin theta, I'm sorry, cos theta dr by d theta I unit vector plus like that someone, then someone can try what it comes. This is certainly it is complex and that was easy. Anyway, now it came to our surveillance, then can we use xy instead of r theta? Because after all, it is this is what discussion we are pursuing. After all, it is xy axis. This is x axis, this is y axis. Can we try calculating the ith section area in x and y? What is your x and y? This is ith section. If this is x axis, then radius is going from here to here to here. It is making delta xi. Radius is going from here to here. It is making delta yi. Okay, in that fashion, if I represent this, if this point is xi plus yj, if represent this as a length vector, arc as a length vector, cross product of these two will give same thing, dp by dx cross dp by dy. The way we did dp by dr cross dp by d theta, here it will come as dp by dx cross dp by dy. Magnitude delta xi or dx dy, delta xi delta yi. But problem here is if I take this, then x and y has to be independent to each other. If I had drawn polar coordinate system inside Cartesian coordinate system, then r and theta are independent and x and y are dependent on r theta. But here I am taking x and y in xy plane only, where y is dependent upon x. So this will not work. Dp by dx cross dp by dy magnitude delta xi delta yi will not work, because delta y is function over x. In that fashion, dp p is xi plus yj, y is function over x, means dp will become a function over x only, a vector function over x only by x. If I change x, then how much x will change? This is weird. It will not work. So both has to be independent, x and y. To get both independent, then we went to third thing. Okay, if two guys are fighting, they cannot settle down. Okay, if two guys are fighting, they cannot settle down on their own. They need third part. If I want to get area in r and theta, it's not possible in r theta plane, because r and theta are, they cannot solve it. I came to xy plane and there I drew r and theta, where r and theta become independent. If I want in xy plane in x and y, it's not possible. Two guys, they cannot settle down each other's fight. Both will say, I am very nice. They need third part. So we went for 3D model. If I have a 3D model, then we took a sphere for simplicity. We took a sphere for simplicity. Then what we did is that consider this is xy plane. If this is xy plane, then this sphere is center at the xy plane. What I'm trying to say, that center of this sphere is coinciding the origin. In that fashion, half of the sphere is above xy plane and half of the sphere is below xy plane. If I take any point P here, then this point is x comma y comma z. Or if I take any point P here, whose height is z, at P, if I place a straight line, it will go and fall on xy plane. This is x axis, this is y axis, this is z axis. This point, if I draw a vertical line, it will fall on xy plane. If it falls on xy plane, and that is x comma y, then x comma y both are independent and z is dependent. From point P, I can draw a line like this, circular line like this, where y is constant in xz plane. At point P, I can draw a line like this, where x is constant in yz plane. Then now at point P, I have two circles. One circle in xz plane and one circle in yz plane at point P. Okay, if I take this as a length vector and this as a length vector, if I do cross product, I get the some functionality of the area around P. Makes sense? Okay, in that fashion, now I have two circles now. This is point P, and I have I made a circle like this where y is constant. Point P is x comma y comma z, xi plus yj plus zk, where z is function over x and y are independent to each other. Z is dependent upon x and y. Okay, this is the length vector at point P. Similar fashion in yz plane, this is point P. This is the length vector at point P. What is the What now I have, if I take xz plane, then this is x axis, this is z axis. X is variable. In yz plane, y is variable and this is z. Okay, if I take the cross product at point P of two lines, then one line is xi plus yj plus zk. Another line is again xi plus yj plus zk. First, I'll take out x, considering x is independent here. It will become I plus y by xj plus z by xk, bracket close into x. It will become I plus dy by dxj plus dz by dxk, bracket close x or dx or delta x, whatever it is. The inside term, it is exactly equal to dp by dx. That is I plus y by x j plus z by x. Division I can change into differentiation. So it becomes I plus dy by dxj plus dz by dxk. It would become dp by dp by dx into dx or delta xi. What is delta xi? If I chop x-axis into n part, or if I chop this line into n part, then ith part is the delta x width. Okay, delta xi. Similarly, if I do for this circle, then it will be, I have to take out y, because y is changing. In that fashion, it will become dx by dy plus j plus dz by dy k, bracket close, delta y, j of the jth section, if I chop it into n part. Okay, in that fashion, that can be written as dp by dy. Here dp by dx, it is similar to dp by dx cross dp by dy, bracket, and then delta xi delta yj. Okay, this is the area of what? Okay, now we will rephrase it. Dp by dx cross dp by dy, it is same as dp by dxy. What is your dp by dxy? Dp by dxy, if I see, then it will, if this is xy plane, if this is xy plane, and this is the hemisphere we are talking, top hemisphere. This is the top hemisphere above it, and this is point P here. Okay, and P falls on xy plane at a point called, P falls on xy plane at a point called x comma y. What is dp by dxy? If there is one unit of area change around x and y, how many of area change I see at point P? At point P, how many area I change? Per unit area change in xy plane brings how many area change in P? That is dp. Actually, it is dp by dx cross dp by dy. If I merge it, it becomes dp by dxy. Per unit area change in xy brings how many unit area change in P? If that is the case, then if I multiply with the delta xi and delta yj, then I get the area change in the ith section here and jth section there whatsoever. This is how it is. Anyway, now the question is arising that delta xi and delta yj. Okay, but you said you are trying to calculate the area of a circle, and we are in phase of calculating area of a surface area of a sphere. Okay, dp by dxy, delta xi, delta yj. Okay, area of a 3D surface we are in phase of calculating, but we want area of a simple circle. Hold on. Okay, now instead of a sphere, let's take a cylinder. Okay, if I take a cylinder is kept on xy plane, where the lower circle is same as a higher circle. If I talk in the area, that is cylinder. Now consider the P point was there on the sphere. P point is on top of this this cylinder. In that fashion, what is the area fundamental here on around point P? That is dP by dxy delta xi delta yj, where xi, this is the vertical, there is no vertical circle here. If I cut in a vertical fashion, it will go flat like this, and then it will go like this, and it will go like this. It will be a kind of rectangle. Okay, if I cut in xz plane, it will be a rectangle. If I cut in yz plane, it will be a rectangle. I don't mind it. Okay, idea is that if I idea is that at point P, the area fundamental is dp by dx cross dp by dy, dx dy. Okay, that is the concept. Now, now let's break it. dp by dx cross dp by dy. If I break it, it becomes d of p. P is xi plus yj plus zk by dx. It becomes I plus dy by dxj plus dz by dxk. Okay, and then or okay, if okay, let's go little behind. What is the area calculation we have done around point P? That is dp by dxy plane delta xi delta yj, means if I take this circle, then I if I take this line and this line, two line I'm taking at point P, one in xz plane and one in yz plane. Now I have to write like, if I'm trying to calculate, okay, let's okay, in that fashion now we have dp by dx, dp by dy. dp by dx is I plus dy by dx plus dz by dx. What is dy by dx? Y is constant if I make the this circle. One circle or one, now in case of this cylinder, it is a rectangle. In xz plane where y is constant, dy by dx is 0. dz by dx. If I talk about z, that is the height. Z is not changing again. Z is flat. It is not a sphere that Z will keep changing. If I take a cylinder, Z is everywhere constant only. Z is not changing. Okay, on this top circle. dz by dx is 0. Only I will remain. Similarly, dx by dy, I plus j plus dz by dy. Again, all are 0, only j will remain. I cross j, delta xi delta yj, it will become k vector. K vector delta xi delta yj. What is delta xi and delta yj? Okay, if I take delta x delta y, this is the top circle. This is the top circle. I chopped in this manner and then I chopped in this manner. Okay, if I chop in this manner and this manner, then it is something like this. Okay, more or less, this is, if I do like this is x-axis. Makes sense? This is y-axis, this is z-axis. If I rotate it to make it clear, this is delta x and this is delta y. Makes sense? More or less, it came as now k vector delta xi delta y, if I make it I only, delta yi. Okay, summation I equal to 1 to n. The way we started our discussion, what is the area of the ith section? We started a discussion, if I have a circle, then what is area of the ith section? If I chop it into, if I chop it into kind of like this, this is the radius. I chop, I'm sorry, if this I chop this circular region, I chop this circular region into n different parts. So looks like the way we are proceeding, it is something like that, that I'm chopping x-axis into n number of parts. Okay, I'm chopping x-axis into n number. The way we are proceeding our discussion, it looks like the way we chopped to get the area in the polar coordinate system where radius, where angle was chopped. Okay, now consider that I am chopping the x-axis and then I am chopping the y-axis. Makes sense? I'm chopping the x-axis and chopping the y-axis. Think in this fashion, the way I am taking. Because for cylinder, this is the base circle and this is the top circle and this is the cylinder. If this is the cylinder and if I am talking about this, this cut, xz cut and yz cut, if this is delta x and this is delta y, looks like I have cut the circle into x-axis into n part and y-axis into n part. Okay, for a particular section we have delta xi and delta yj. What is area of this circle? We started with the polar coordinate system. Now we have transferred into, now I'm rephrasing all the scenario again. I'm trying to calculate area of a circle. To get the area of a circle, this is x-axis and this is y-axis. If that is the case, this is x-axis and y-axis. If that is the case, I chop the x-axis into n part. I chop the y-axis into n part. I have so many area subsection. Each area subsection has a width of delta xi and delta yj. Make sense? Now to find the area of a subsection, I have to do cross product in this direction and in this direction. To get the cross product of this length vector and this length vector, if I try to do cross product of these two vectors, then it will be cross product of xi plus yj. I'm sorry, one length vector is, if I talk about any position vector p here, then that is xi plus yj. If I take out x and if I take out y, it will become I plus dy by dxj, dy by dxj, dx, dx by dy, j plus dx by dy, I plus j, dy. But we cannot do that, because to have the area, if I talking about two variables x and y, both should be independent to each other, so it was not possible. Now when we are calculating x and y in xy plane, both are independent to each other, whereas height is dependent upon x and y. In that fashion, we took xz plane and yz plane, where x is variable, x is independent component, then z is dependent component. That is the one circle we talked about. If I took the sphere, this is point P, and if I cut it, then x is independent and z is dependent. We divided the problem. And if I take another circle, then y is independent and z is dependent. But if I had try to calculate the area of a circle in xy plane, then it came as dx dy, where y is dependent upon x. It's not possible. Now we took z is dependent upon x, we took z is dependent upon y. In that fashion, at any point P, if I try to calculate the area of the 3D, then it will be cross product of two vectors. Okay, then it becomes dp by dx cross dp by dy, dx dy. Okay, now instead of a sphere, I converted into the cylinder. Okay, same thing, dp by, now point P on the sphere lateral area, now it is on the top here, dp by dx. Now if I cut like this, it will be a rectangle. If I cut like this, it will be a rectangle there also, doesn't matter. If I try to calculate area here, it will be dp by dx cross dp by dy, where dp by dx if I do, then y is constant, z is also constant, z is not varying. It becomes I vector, dp by dy, where x is constant, z is also constant. dp by dy becomes dx by dy I plus j plus dz by dy. Okay, all become 0 except j. Here all become 0 except I cross j, k vector. K vector, delta xi, delta yj. What is delta x, delta yj? If I have taken this is x-axis variable, this is y-axis variable. X we cut into n part and y we cut into n part. Ith section in x, jth section in y. So if I go with this area, actually I am trying to calculate area in 3D model, not in 2D model. 3D model I am trying to calculate the surface area. But surface happen to be a circle only. Knowingly, actually we are getting the area of top circle, not the bottom circle. Concept is to get the area of the bottom circle, not the top circle. But both are same, luckily, in the cylinder. And there dz by dx is 0. If dz by dx is not 0, then it will be a sphere, where we have to calculate it. Okay, now we have the summation for the area of the surface area of the top circle, that is I equal to 1 to n, j equal to 1 to n. We are not calculating we are not solving our problem. Our problem is to solve the area of the circle, that is the base circle of the cylinder. But we are calculating the surface area of a cylinder of the top part, where z is constant. We are calculating the surface area of the top part. Luckily both are same. Okay, in that fashion, it will become summation I equal to 1 to n, summation j equal to 1 to n. Make sense? Okay, summation j equal to 1 to n. This is the surface area of the top circle. And then we have k vector magnitude, that is 1, delta xi of the ith section, delta yj of the jth section. Okay, now we can rewrite as summation I equal to 1 to n, summation j equal to 1 to n, 1. 1 is function over x and y, and delta xy. This will come as same as x axis and y, I'm sorry, xy axis and function over xy axis. This is xy axis, this is function over xy axis. If that is the case, then this is delta xi of the, I chop this xy axis into n square part. This is the ith part, that is delta xi delta yj. This is the, I rephrase, what is the summation? I equal to 1 to n, j equal to 1 to n. Okay, and then we have delta xi delta yj. Rewrite it. Now say there is alpha, alpha equal to 1 to n square. Function over x and y, that is 1. And delta xy of the alpha. If I cut this xy line, this axis is xy axis. Delta xy. Consider xy is the axis. Then I chop into n square, and this is the alpha section. Then this height is function over xy of the alpha section. If I multiply this height with the width, this is the alpha section area. If I add all this, it becomes full-fledged integration. That is integration of x and y from lower limit to higher limit. And then we have d of x and y, dx dy, lower limit to higher limit. What is lower limit to higher limit of the higher section circle? If I see like this, then x is from minus a to a, and y is changing with the x. Y is not rectangular region, it is a changing. So x will be minus a to a. If I take full circle, then a will be, x will be a and back to a, then it will give full circle. And y will be minus square root of a square minus x square to square root of a square minus x square. That will give the full circle. X is a to a, but it looks difficult. So we will say x is minus a to a, then I have to multiply by 2. 2 into x is minus a to a, and then y equal to minus square root of a square minus x square to square root of a square minus x square, dx dy. Solve it, it will become pi r square. Now we'll come to the previous thing. We had, at the beginning of the discussion, we had said that we are chopping the circle in the circumference. We are chopping the circle in the circumference in a way that this is the ith section of the area. This is the ith section of the area where it is chopped in this fashion. And we took this as x vector. We had taken this as a x vector, and this we have taken this as x variable, a y variable vector, and this is as x variable vector. Okay, and that fashion we try to calculate the area. It doesn't matter. Okay, either you chop x axis into n part and y axis into n part and take delta xi delta yj, or you chop the radius angle into n different part. In that fashion, this is delta xi and this is delta yi, delta xi delta yi, or you chop this x axis in n part and y axis in n part. Then there will be a area like this, that is delta xi delta yj. Or if I chop in angular fashion, then this is the ith section. Okay, this is the delta xi and this is delta yj, whatever. Okay, and the end we try to calculate the area of the 3D model, and that is the surface area. We close all our discussion. We are not worrying about calculation of the area in xy plane. If I take the sphere, and a sphere is hitting the xy plane, then this is the region, circular region, that is coming to the xy plane. Okay, and if I am trying to calculate dp by dx cross dp by dx, we are trying to calculate surface area here. If I integrate over, we'll get the complete surface area of the sphere if I place the limit. Okay, but we are making a special case where P is not lying on the sphere, P is lying indeed on the top part of a cylinder. But fundamental will be same. The area around P will be dp by dx cross dp by dy, delta xi delta yj. More or less, Knowingly, unknowingly, we discarded our actual problem to get the area of a circle that is sitting at the base. More or less, we try to calculate area of a 3D model where z is not variable. If z is not variable and we are trying to calculate the area of surface area of this cylinder, then it will come surface area of the top only. Means more or less we calculated area of the top 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 part where we have delta x and delta y. Delta x is chopped in along x axis. If this is the top circle, then this is the top circle. Delta x is chopped like this and delta y is chopped like this. I forgot the actual problem and I solved the circle area of the top part where we chopped x-axis and y-axis and we got. Luckily, the top circle and bottom circle area is same. So ith section area, if I chop x-axis and y-axis and get the ith area section, that is dp by dx cross dp by dy magnitude delta xi. The ith section, if I chop if I chop x-axis into n part, then ith section chop, that is delta xi, and if I chop y-axis in n part, then jth section delta yj. That will be the area of the 3D model of the along x-axis. I'll represent. So it is more or less we are trying to calculate the surface area of a 3D model where if this is xy plane, this is x-axis, this is y-axis. If I chop x-axis into n part, if I chop y-axis into n part, and if I go up, then it forms a surface area on a sphere. Okay, in cylinder it will form surface area, full surface area of a cylinder, but I am keeping z constant. In that sense, it will be surface area of the top part of the cylinder. Okay, there we have x-axis, and there the ith section area will be summation I equal to 1 to n, summation j equal to 1 to n, dp by dx or dp by dy, magnitude delta xi delta yj. Now, if I sum it, then it will come to integration, and that will be whatever we said, x minus a to a into 2, y minus a square root of a square minus x square to square root of a square minus x square, dx dy. If I integrate dy first, it will become 2 into a square root of a square minus x square. 2 I can 2 I can keep outside. Okay, let's see. 2 I can keep outside. In that fashion, it would become a square root of a square minus x square dx. What will be integration? If I take x as a cos theta, a will come out. Sin theta, a minus sin theta, a square minus sin square theta d theta. A square I can keep outside. Now we have 4a square outside. This is what I think. 4a square outside. And now we have sin square theta d theta. Integration will be theta by 2 minus sin 2 theta by 4. Minus is there. I just leave it. Now angle is 0 to 2 pi. Angle is 0 to 2 pi. Theta by 2 minus sin 2 theta by 4. Angle is angle, I'm sorry, if I am converting like this. Okay, let's proceed. Now we have theta by 2 minus sin 2 theta by 4. What is angle? If I take a circle and x is minus a to a, angle will be 0 to pi only, not 2 pi, 0 to pi. And theta by 2 minus sin 2 theta by 4, it will become pi by 2. Pi by 2 outside 4a square, 2 pi a square. Outside it is 4 pi a square. And here we have angle as 0 to pi by 2. It is coming as 2 pi a square. That is wrong. So 2 somewhere, 2 I have taken it wrongly. So it will be pi a square. Someone can fix it. Okay. So this is the way to calculate the area of a circle when we do cross product of x length vector and y length vector, and it has to be settled down in 3D. We cannot do in 2D. I was trying meanwhile to settle down in theta r plane. If this is theta r plane, this is xy plane. First, we settle down theta r into xy plane and we calculated the area as dp by dr cross dp by d theta dr. Can someone settle down xy into theta r plane? Okay, then we can do dp by dx cross dp by dy because xy is independent here and r theta are dependent here. Okay, we will do in next session. Can we do x and y? X and y we merge into theta r plane. Now we have xy as independent and theta r as dependent. Now we can go dp by dx cross dp by dy dx dy in theta r plane. In xy plane it is not possible. In xy plane if you want, then we have to come to 3D model. And then we have the 3D model will be cylinder. And top part of the cylinder, that area I have to calculate as a 3D surface. Luckily, the top part is a flat circle where z is constant. Okay, someone can try other ways also. These experiments are not there in any of the book. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610